Hello everyone, thank you for the opportunity. My name is Widiya Rumasoreng and with me are Karyadi and Nindyawati. We are from Civil Engineering Department, State University of Malang, Indonesia. In this occasion, I will present to you about my research paper entitled Pull-out Resistance of Glued-in Rod Embedded Parallel to Grain in Laminated Bamboo with 2 edge distance variation. This title is present in First International Conference on Emerging Issues in Technology, Engineering and Science. Chapter 1, Introduction. The utilization of laminated bamboo as a building construction element in the form of beam and column requires the connector tool support. And glued-in rod is a new connector that is currently developed. But there is not much research on glued-in rod connection in laminated bamboo. So there is still a little information about the mechanical properties. Further research is needed on glued-in rod joints in laminated bamboo. There are various variables that affect the mechanical properties of glued-in rod. There are rod diameter, anchor length, adhesive type, adhesive thickness, edge distance, and etc. With a thin-walled hollow beam or column cross-section, this is the thin-walled hollow beam or column cross-section. Further research is needed on glued-in rod joints in laminated bamboo with the influence of the two outer edge distance of the steel rod. And this picture shows the two outer edge distance of the steel rod. In this research, we take two outer edge distance of the steel rod as the variable. This study analyzed the effect of diameter and steel rod distance from two outer edges to the mechanical characteristic of rod embedded parallel to grain on laminated bamboo. The mechanical characteristic including pull-out resistance, the shear strength, the damage types or damage pattern, and the slip modulus. Chapter 2, Method and Materials. To form the laminated bamboo, we use Dendrocalamus asper or petung bambu. And adhesive for laminated bamboo, we use urea formaldehyde from one-step glue brand. And the rod, we use threaded steel rod with diameter 8 mm, 10 mm, and 12 mm. And the steel rod was embedded in the drill hole filled with epoxy resin adhesive from Cicadur 732 brand. Samples. The testing objects were cut in 160 mm length, 100 mm thick, and width following the variation of the steel rod distance or XD. In this picture you can see that were 2.5 times D, 3 times D, 3.5 times D, 4 times D, and 4.5 times D, which D is the threaded steel rod diameter. And the diameter of threaded steel rod, we use 8 mm, 10 mm, and 12 mm. The anchor length is 40 mm. The adhesive thickness or the black part in this picture is 3 mm. There are 15 treatment groups with 5 samples each treatment. So there are 75 testing objects in total. Testing. The testing configuration in this research is pull press. The threaded steel rod will be pulled and the laminated bamboo in this area will be pressed. The main data we get from the pull-out test are load and slip. The slip rate was measured using a dial gauge. You can see the dial gauge in this picture at the area with the red circle. We move on into chapter 3, result and discussion. This is the table of maximum load and shear strength. This table shows the data of rod diameter, mean of maximum load, edge distance, and the shear strength. From the table, there is influence of the distance between the steel rod and two outer edges of laminated bamboo to the value of the shear strength. We can take example at the same diameter 8 mm, the greater the edge distance, the greater the shear strength calculation result. This is the chart of edge distance and mean of maximum load relationship. From the chart, there are influence of the distance between the steel rod and two outer edges of laminated bamboo and the rod diameter to the value of maximum load. The explanation: at the same diameter, the greater the edge distance, the greater the mean of maximum load. And the minimum distance between the steel rod and two outer edges of laminated bamboo before experience pull-out strain reduction for diameter 8 mm, 10 mm, and 12 mm were 4 times D, 3.5 times D, and 3 times D respectively. This is the table of types of failure. Based on the table, 30 specimens among 75 testing objects experienced damage from the bond between the adhesive with the bamboo or the adhesive with the treated steel rod, or damage type 2. And 45 testing objects experienced damage in which the steel rods were pulled out along with the laminated bamboo around the adhesive, damage type 3. And all the objects in all diameter variation 8 mm, 10 mm, and 12 mm experienced splitting damage when they were in 2.5 D distance between the steel rod and two outer edge. This is the graphic that shows the load and slip relationship for each diameter. This is for 8 mm diameter specimen, this is for 10 mm diameter, and this is for 12 mm diameter. The figure shows that all variations have the same trend line, thus all the decrease during the testing was brittle, in which glute inroad underwent reduction without any decrease in the load gradually after the peak load. If you see at the graphs, after reaching the peak load, the line suddenly dropped, indicate a brittle failure. This is the table of slip and slip modulus calculation result. The slip data we get from the pull-out test is used to calculate the slip modulus value, or KS, using this formula, which Fmax is the peak load, D04 is the slip at 40% Fmax, D01 is slip at 10% Fmax. From the slip modulus calculation result, we get that the distance of the steel rod to the outer edges does not affect the value of the slip modulus. But there is influence of the distance between the steel rod and two outer edges to the slip. We come to the conclusion for this research. The distance between the steel rod and two outer edges of laminated bamboo influenced the pull-out resistance, shear strain, and slip, but it did not influence the value of slip modulus. That's everyone. That's what I wanted to share with you in this occasion. Thank you.